$8,000 versus $63,000. Same task, same year. One of those numbers belongs to the best AI that money can buy right now. In a moment, I'll tell you which one. But here's the problem. Two researchers just used 60-year-old computer science math, theorems that have been settled since before the internet existed, to prove there's a hard ceiling on what these LLM systems can actually do. And then a separate team built the simulation to find out exactly where that ceiling sits in the real world. Those two numbers I just mentioned are part of what they found. And the $55,000 difference between them is the big story here. For the past year, we've been drowning in a very specific kind of content. Non-stop doom and gloom narratives about the AI apocalypse. AI is going to take your job. AI agents will ruin your business. The corporations building this stuff have been making promises, ones that have real consequences, and bosses are already firing real people based on these pie-in-the-sky promises. Not because they have proof it will work, because they've been wowed by demos and non-stop hype, and probably because someone above them is pushing for cheap, tireless, mistake-free labor. Every AI demo you've ever seen was designed, intentionally or not, to stay below what AI researchers call a complexity ceiling. In plain terms, every AI model has a fixed amount of computational work it can do per response. Some tasks fit inside that budget, but others, specifically when dealing with complex business processes, don't. And with these complex scenarios, AI models either fail or hallucinate. Demos that are given by these companies are, by definition, only showing tasks that fit. They would consider this good marketing, and technically it is, but it's also something else. Misleading by omission, because there's often a very large gap between what you see in a controlled demonstration and what actually happens when you deploy that same tool in a real workflow. The metric you're being wowed with is what I'd call capability at peak. What the model can do on a single, well-scoped example. The metric that actually matters to any business, though, is coherence over time, or what happens as the chain of tasks gets longer, more complex, and more dependent on earlier decisions holding up. That second metric is rarely discussed in any AI product pitch, because showing it would reveal that the workforce replacement promise, the one your CEO is betting your colleagues' jobs on, has no real-world data behind it. In July 2025, a father and son published a paper that almost nobody noticed. It was called Hallucination Stations, on some basic limitations of transformer-based language models. It sat quietly on Archive, an academic preprint server, where researchers publish work before formal peer reviews, for 6 months, before Wired wrote about it in January 2026, and the AI community finally started paying attention. The father is Vishal Sikka, former CTO of SAP, former CEO of Infosys, and a Stanford PhD who studied under John McCarthy, the man who coined the term artificial intelligence. His co-author was his teenage son, Varun, currently at Stanford. That's a credibility profile worth taking seriously. The paper hasn't been peer-reviewed, a real caveat I'm not going to gloss over, but the math they're drawing on isn't new or speculative. They're applying computational complexity theory, settled science since the 1960s, directly to the architecture of modern LLMs. Their core claim is beyond a certain complexity threshold, LLMs cannot perform agentic tasks reliably. And equally critically, they can't verify whether their own outputs are correct. The ceiling is architectural, baked into how transformer-based LLMs do their work. And here's the part the industry really doesn't want to sit with. A more powerful version of the same architecture doesn't move that ceiling. It just lets you get closer faster. So that's the theory. Now let's look at what it looks like in the real world. There's a research lab called Anden Labs that built something called Vending Bench 2. It's currently considered the gold standard for testing AI agents on long horizon tasks. The setup's simple. Each model is given $500 and tasked with running a simulated vending machine business for a full simulated year. The agent has to source inventory, set prices, manage suppliers, pay daily fees, and hundreds of sequential decisions to maximize its final bank balance. The results of running this simulation do not at all support what AI CEO presentations and pitch decks are trying to convince you of. The current leader on the Vending Bench 2 leaderboard is Claude Opus 4.6, Anthropic's most capable model, with a final profit of roughly $8,000. Google's Gemini 3 Pro comes in around $5,000, and the other models trail significantly. Andon Labs calculated a theoretical human ceiling for the same simulation, what a savvy, optimal human operator could achieve under the same conditions, and that number is approximately $63,000. The best AI agent on the market right now is achieving not 80%, not 60%, but less than 15% of that ceiling. And the reason isn't that the models are bad at individual tasks. The reason is specifically what the Sikka Paper predicts. Agents don't fail immediately, they lose coherence over time. Small errors compound. The chain of logic that was holding together at step 10 is quietly breaking down by step 40, and the model has no internal mechanism to detect that it's happening. You can see this in the actual failure behaviors the benchmark documented. In some runs, agents were socially engineered into giving away their inventory for free. In another instance, an agent attempted to contact the FBI to report its own $2 daily location fee as fraudulent bank activity. These aren't quirky one-off bugs. They're what mathematical degradation looks like when it plays out over hundreds of sequential decisions. The model loses the thread of its own logic and keeps generating plausible-sounding next steps regardless. I've seen this firsthand. When I use AI coding tools for architectural-level planning or project-wide refactors of software, a single wrong assumption early in the process can quietly poison every step that follows. And because each step is built on the previous one, by the time the problem surfaces, it's often impossible to untangle. You can't patch your way out. You just revert the whole thing and lose hours of work. That's not a vending machine simulation. It's a real project with real deadlines, and it happens in scenarios far simpler than a full year of business decisions. So, if this gap is significant, why isn't anyone talking about it in the spaces where AI is being sold? The answer isn't going to shock you, and it's not complicated either. Marketing demos are short. They typically show you a small set of contrived examples with a finite number of steps. Can the AI do X is always going to look better than can the AI sustain X across 300 independent decisions? The first question has a great answer. The second one has the vending bench numbers. But I want to be precise about what's happening here because it's just marketing is too soft a frame. What we're looking at is the active suppression of known capability features. These companies understand the architectural constraints. Their own researchers publish papers about them. And yet the public-facing narrative, the one that's influencing hiring decisions and business deployments right now, continues to make claims that these systems are not capable of supporting. It's not a gray area when you're making public claims about what your product can do while your own internal research documents a hard ceiling on that capability. You're not overselling, you're misrepresenting. And with hundreds of billions of dollars at stake, the incentive to keep doing this is enormous. And the practical consequence is that companies are already laying off thousands of workers based on these unproven promises. So what do you do with this if you're someone who's actually using these tools or making decisions about them? First, stop evaluating AI on single task demos. That's the metric designed to impress you. Start evaluating on chains. And here's what that actually looks like in practice. Take whatever workflow you're considering automating, and instead of running one clean demo, give the AI a sequence of 20 to 30 decisions, where each step depends on the previous one. Watch where it first loses the thread, and that's your coherence ceiling for that tool on that task type. Then try this. Deliberately introduce a small error early in the chain, a wrong number, a misframed assumption, and see whether the model catches it and corrects, or whether it compounds the error across every subsequent step. That second test is essentially a DIY verification check, and it'll tell you more about whether you can trust that tool in a real workflow than any benchmark score or product demo ever will. The questions you actually need to answer before deploying AI in any serious capacity are: how quickly does the performance degrade as the task chain grows? Where does a human checkpoint need to sit to catch errors before they compound? And if the chain breaks at step 40, what's the blast radius? Those are engineering questions. The AI industry is mostly answering different questions. Can it do this thing? Because that one is a better answer. And if your plan is to let your development team go and keep one senior engineer to review AI output, you haven't found a shortcut. You've just moved the failure point. One person cannot catch what 30 would have. And the AI won't tell you what it missed. There's no version of this that works without adequate human oversight in the loop. The ceiling the Sikka Paper describes is real. The vending machine benchmark data puts hard numbers on it, and none of this means these tools aren't useful. I use them every day, and they're genuinely exceptional for the right application. But you can't build reliable workflows around AI if you're measuring the wrong thing. And right now, almost everyone is being handed the wrong measuring stick. And that's what we'll dive into next. Why AI's biggest blind spot isn't its intelligence, it's its lack of self-awareness. What does that mean for the workflows you're building? Stay tuned. And have you seen AI fail in a long chain task? Drop a comment below. I'd love to hear your stories. And don't forget to hit that like button if this content made you think more clearly about agentic AI situations. And don't forget to subscribe, because I'll be covering more and more topics just like this. See you in the next one.